I am Professor Leandro França, and now I'm going to talk about our project, about our work that is free and open source software solution in the GeoRondônia Project, efficient georeference the rural settlements with QGIS and GeoINCRA plugin. The project is this, and I will talk about that now. Okay, and the GeoRondônia Project aims to address 3 key goals, and we will talk about these goals and the solution in QGIS. But we will see the study area, the state of Rondônia in the Amazon. We will talk about the methodology and about the GeoINCRA plugin that is used here in Brazil, and the results and the benefits, the future improvements for this plugin, and conclusion. The letters is a little small, but I will read here. The GeoRondônia Project aims to address the key goals: occupational supervision for 25,000 families in the rural environment registry for the same number of properties, and the georeferencing of rural properties. This ambitious project is supported by the partnership between IFRO and INCRA. The georeference process, while essential, is a complex and resource-intensive, here free and open source solution like QGIS and GeoINCRA plugin play a transformative role. The National Institute of Colonization and Agrarian Reform, INCRA, this symbol here, INCRA, is a body of the Brazilian federal government linked to the Ministry of Agriculture, Livestock and Supply. Its main mission is to execute national agrarian policy promoting agrarian reform and land planning in Brazil. The georeferencing of rural properties is a complex process that requires knowledge in surveying, legal aspects, precision, and efficiency. Here below we have the link, the page, homepage of the GeoRondônia Project that is organized and managed by the Federal Institute of Rondônia here in the Amazon. So our study area is the all state of Rondônia in the Amazon. Here you can see the state and the settlements project. Settlements project to distribute area for locals who use that land to plant and agriculture, livestock, and our federal union properties, but is distributed by the people. And INCRA is responsible for that. Here you can see the legal Amazon, and here is the state of Rondônia, not near here, but it's a great state from Brazil. And the methodology is the tracking with the GNSS, with the precision and accuracy necessary to define the coordinates of the limits of the property. There he used GNSS receivers, and they are processed using the IBGE. It's a geographic organization from Brazil that rules the procedures for GNSS collecting data. The method for collecting the data with GNSS or GPS, it was the static mode with average time of 30 minutes in each point. After that, we have the point of the limits of the area with the precision, and the area of the settlements is divided by the properties, and everything of this is prepared using QGIS. So they use the creation features in QGIS. They use also LF tools. That's also another plugin that I developed. And GeoIncra plugin. This plugin, I had the help of Thiago Prudencio. He is here. Thank you very much for all the community. And we use a database, a standard of layers, fields, all type of fields, and this is the main solution for have a procedure methodology to automate all the procedure. So the main product of the georeferencing for INCRA is a spreadsheet with the extension ODS, where I use LibreOffice Calc, a spreadsheet of open source software. The spreadsheet is uploaded in the system of INCRA that is called CGF. And the CGF has the main purpose to verify overloop inconsistency related to the properties, related to the polygon of the areas. After that, we can say that the property is regular, is okay. We have the regularization, and here is the launch of CGF, and everyone in the Brazil and the world can find, search for rural properties in Brazil with using the GeoIncra plugin. Here you can see for the creation, to feed the ODS spreadsheet, we need some layers, like the limits, point limits, the method that was used in the survey, the precision for each coordinate, and the cartographic system. Here in Brazil, we use the CIRGAS 2000, and about the property of the holder, name of the property, and several information is in this spreadsheet. Here you can see the plugin in the QGIS, the name GeoIncra, so you can search for any property, rural property, with just drawing a rectangle in the area in QGIS like this. Just draw a rectangle, and you can see the rural properties and all the attributes in the attribute table. We can download other information about the technical responsible for the survey. This is very important. And these open layers that we use, just double FS. But the easy part is to load as a scratch layer, so you can save as shapefile, GeoPackage, and other formats like KML and load in the Google Earth or other software. But we do everything in the QGIS for create and update the spreadsheet. Here you can see GeoINCRA and LF tools and other tools. I just show you the tool called Consultar Base do INCRA, or Search INCRA Database. Let's talk about some of the tools. We have the first tool to feed the vertex from survey in the database with all standards, precision, names, and the modes of the survey. Everything is loaded in the layer using this tool. We can download the ODS spreadsheet, the empty model to work. So CGF is the system of the INCRA to standardize the work for all workers, surveyors. So the surveyors need the specification. So here in Brazil, we have a very good specification for surveying rural properties and to divide the rural properties and normalize the use and surveying of these things. We have we can transform formats like CSV that is downloaded to CGF and load in the database using, it's very important there to know the Z coordinate, because the Z is used in the area. The area is calculated in the local tangent plane. So properties in the highest locals has different areas for comparing with properties in the sea level. We have difference because of the different heights. So this is considered when you use Z coordinates. This is we need to do that when we are surveying. We can generate TXT for ODS, just a way to see the coordinates, all the information. It's easy to copy and paste in the ODS. And we can create directly the ODS using the database, the layers that we have. The layers, let's see here. It's very simple, just a point layer, line layer, and polygon layer. Each layer has different information about the limit, point limit, the boundary, the neighbor information, and the polygon has the holder information, the people, the property information. Everything is in the polygon layer. And here we can see just one spreadsheet with some information. We can see the property information and the coordinates. The projection is a little small, but you can have faith that this is numbers and precisions and all information about the limits, the vertices, and the polygon area. One of the major innovation of the project is to automatic generation of ODS spreadsheets for hundreds of properties, or 1,000, because if you have polygons, we can automatically create the boundaries, the limits, the line between two neighbors. You can create automatically the vertices, all the vertices. You can name the vertices, and everything is now automatically generated by this project that help us to develop this solution. And the results and benefits of this project is the process of automation. When we have standards, when we have norms, and a database with the structure that is needed, we can automate organization. The key word is organization. So when we have organization in our project in QGIS, you can use tools like those that you can create files, any kind, because Python is a very good language, programming language, and we have a library for everything. So you can create ODS, text, XT, and other formats. We have automation product generation, ODS spreadsheet, that were previously created manually are now generated automatically. Time reduction. So they found me, the project found me because of the plugin. So they helped us. We are here because the Rondônia project, and we helped them in the program language to use the tools to fill all the information. And now they are doing 100 or more settlements, properties of a settlement in one day. So the hard part of the work is the survey. Survey, you need to go in the field, track GNSS, but the work that is used is did in the laboratory is very simplified because of the QGIS and GeoINCRA plugin. Error elimination, we also developed some validation routines for finding duplicate nodes, invalid geometries, several of inconsistencies that is natural when the people are vectorize the things. But we produce a routine to eliminate almost everything of errors, because it's very important to maintain the connection between the polygons. They cannot overlap, and everything you know about topology. A cost saving, QGIS is free. GeoINCRA is also free, and both eliminate need the expensive license in Brazil. In Brazil, we have some softwares that do this work, but they are expensive, mainly for universities, institutes, because the license is only for one computer. Okay, thanks. And cost savings is one of the most important for the project. And with the money saved, we can go to the conference, travel, and et cetera, et cetera. Thank you very much. Let's see here. Future improvements. I have only 5 minutes, but we are creating some new tools. For instance, to parsing PDF files to see the PDF from INCRA and create the layers, point, line, and polygon very fast. It's very important for the regularization, like INCRA and others that wants just to see the PDF in the QGIS. The spreadsheet generation for special cases like inner holes, visualization new layers of interest like RBMC of the IBGF, and isn't zones, and etc. And integration with the GeoServer from the G1. We have one GeoServer, we're learning, and we're integrating with our GeoServer also. When the service of the INCRA, sometimes they fall down, and we become available, and you can use our replicated database in our GeoServer. Conclusion, the use of QGIS and the GeoINCRA plugin in the GeoRondônia project demonstrate how the adoption of free and open software can transform georeferencing projects, surveying, by automating tasks, reducing costs, and ensure data quality. The solution significantly contributes to the land regularization, environment sustainability, and socioeconomic development in the region. The methodology developed can be replicated in other Brazilian states. We have this project is successful in Rondônia, but other states has the problem of the settlements and can be used in institutions like universities, etc., can use this model to apply in other states of Brazil. Thank you very much. I think the project GeoRondônia and the regional INCRA from Rondônia and the Federal Institute of Rondônia that help us to be here and share our solution, successful solution in that state. Thank you very much.